Hello and welcome. This is a rudimentary problem involving a truck traveling at 75 miles per hour, and it is braked in a 100% efficient regenerative way so that the kinetic energy is converted into electrical energy. We are to find how much energy in kilowatt hour, the typical unit for electrical energy, how much energy will be stored in the battery. Well, we all know the formula for kinetic energy. We all learned that in physics. But if you use the SI unit for mass in kg and V is meter per second, you're going to end up with a unit of joule, which is a very small amount of energy in thermodynamics, in engineering thermodynamics. So what we do, we want to make sure we always express energy in kilojoule. That's our standard unit for energy. To do so, we divide by 1000. So the formula becomes mv squared divided by 2000. We also take note that we have to convert the given mass and velocity into SI units, which is what? So we got to know what is 1 ton, 1 US ton equals how many kg, and mile per hour, 1 mile per hour equals how many meter per second. And finally, we got to know what is the unit of kilowatt hour versus kilojoule. These are our SI units, and these are the given units. So I want to use this example not just for solving a kinetic energy problem, that would be silly, but how we can use the Unit Converter and the DeskCal, two of the rudimentary apps, basic apps in test website. So for that, let's go. I've already logged in into the test thermofluids.net as a student, and we'll get started. To do so, let's go to the test step page. We could also launch the Unit Converter right from here, but just to show you some of the abilities, because starting from the test step page, you'll have access to all the apps that test offers. So we're going to click the test step and then launch the Unit Converter. Notice that whenever you launch an app, you end up in the hands-on examples, but on the left tab is the real converter. So to find a conversion formula for, let's say, mile per hour, which is a velocity, you can search the search box, or you can go over the measures. It's somewhere there. There's a long list of measures, we call them, for which you can change units. So let's search for velocity. We could search for meter per second or mile per hour. That also will result in the same thing. As you can see, it's very simple to use. Now that we have chosen velocity as our measure, on the left are all the units, on the right also are all the units, except they're sorted differently. Here the top one is SI unit, whereas here the top one is, this is the top one is SI unit and the bottom one is English unit. So we want to convert mile per hour, so obviously that's kind of like an English unit. So go to the bottom, we find mile per hour, and come here, choose meter per second, and your answer is displayed there. Of course, you could enter any number or equations here. So the app is quite versatile on that. So 1 mile per hour, oh sorry, we chose feet per second somehow, is 0.447 meter per second. Let's write it down. So it is 0. Let me pick up the pen again. 447. Sorry. No. So let's convert a ton to kg now. We all know a US ton is 2,000 pounds. But so we go back to the measure, and this time we search for mass. So the ton will be at the bottom, near the bottom. This is the US ton kg. So 907.2. And finally, let's convert kilowatt hour to kilojoule. Go back there. And that's the unit of energy. Or suppose we just type in kilowatt hour. That will bring up energy wherever kilowatt hour appears. So kilojoule is our standard unit. Notice that how even kilojoule is small. So if you go and select kilowatt hour on the right hand side, there we go, kilowatt hour. 1 kilojoule is 0.000278 kilowatt hour. A kilowatt hour is, if you run a 1 kilowatt refrigerator for 1 hour, that's how much power is consumed. Electric stove is almost like a kilowatt. So 1 hour, if you run a stove, it consumes 1 kilowatt hour. It costs about, let's say, average 30 cents a kilowatt hour. So 1 kilojoule, imagine how small it is. Think of the price of that. So imagine how small is joule then. That's why in engineering we start with kilojoule as our basic unit. Now, instead of kilojoule to kilowatt hour, let's press this button and convert. That simply flips the units left and right. So flipping, we get 1 kilowatt hour is 3600 kilojoules. Basically, it's 1 kilowatt running for 1 hour. So power times time is energy. So kilowatt is kilojoule per second. So we multiplied by 3600 seconds. That's how we get kilowatt into kilowatt hour. So everybody should know that already. You don't need a unit converter for that. Okay, but nevertheless, let's write it down that we know how to convert kilowatt hour to kilojoule. Now let's begin the problem. Now, we could easily solve the problem with a calculator, but if you use the DeskCal, you will see how easy it will be run the what if scenario. We can easily change the speed from 75 mile per hour to 85 and see how that affects the calculation. Also, we'll have a record of how we solve the problem. So for that, let's go back and go to a different tab where also I have logged in. And this time, I'll go to Test Steps and launch the DeskCal. Again, the left tab will take you to the app itself. And as you can see, it has two windows. Anything you write here, the result will come in the bottom window. Okay, we begin by adding a comment line given values. And it's a good practice to introduce variable with the unit built in. The mass is given 80 tons. Every statement must end with a semicolon. And the velocity is given. And the velocity is given in mile per hour, mph equals 75. And then we can convert them into SI units, SI values. How we do that? Mass in kg equal mass in ton times 907, if you recall the conversion value, 0.2. And at any time you can do a calculate and you will see the result at the bottom window. In other words, if you make a mistake, it will show up right there with an error message. Likewise, I have calculated the velocity in meter per second, and now let's calculate the kinetic energy in kilojoules, which is mass in kg times velocity in meter per second to the power 2 divided by 2000, if you recall the KE formula. And And finally, kinetic energy in kilowatt hour is kinetic energy in kilojoule divided by 3600. If you haven't made any silly error, then you will find kinetic energy in kilojoules and kinetic energy in kilowatt hour is given here. So we have as the truck comes to a halt, we have stored about 11.3 kilowatt hour of kinetic energy as electrical energy. So which means that's approximately, imagine 30 cents a kilowatt hour. So that's about more than $3 of energy that we have just stored in the battery. Well, now suppose we want to tweak the calculations. We want to know what is the energy stored if the velocity were 85 miles per hour. That is the what if scenario. So all we do is to change the variable and click the calculate button, and all the calculations are updated. Notice the kilowatt hour saved now is 14.55 kilowatt hour. So likewise, once you have test codes, or I call them user codes in a DeskCal, then you can keep it for future regeneration of the calculations. You can simply cut and paste the code here and click the calculate button to regenerate the solution.